The key agenda of our meeting today will be the key areas where the flushing skid needs to be implemented by your sales team or the people associated with your group. Am I correct?
Yes, please.
Okay. And any additional agenda which needs to be covered today?
Sorry?
Any more agenda that we need to discuss today? Any key pointers that you need?
Okay, so on this training you have both the BD team and you have the operators, that is people from the operations department as well. So they need basically knowledge about the loop oil flushing and its competitive advantage.
Okay. All right. So I will try to answer you all the questions in this training session. And after this, if anything gets unanswered, I will certainly write it down and try to get back to you as soon as possible.
Okay.
Right. So now I'll stop my video and we will quickly move to the presentation. So the content of this training session will be the pursuit to system purity, where we will discuss what we need to purify exactly. Second point will be common oil flushing myths that you might face when you are going to uh, demonstrate regarding the product to one of your clients. They might be having some myth associated with flushing that you need to take up vigilantly and clear their doubts. Third will be challenges associated with oil flushing. This operators and of course BD people can uh, take up. After this, the cornerstone of oil flushing, what key parameters of oil flushing you have to take up. And after that, a few live cases where failure has occurred due to flushing, not doing flushing exactly. So we will cover up all this content in our slides ahead. And in case if I am going somewhere way too fast, you may please let me know. So I will slow down. Moving to our first topic, which is pursuit to system purity. In this, you can see there is a certain system in front of you in the picture. System purity means elimination of all unwanted contaminants, not only from oil, but also complete system and the equipments. So in this, if I give you example of a system which is having a few compressors, some certain pipelines and associated valves and everything. So you just need not to clean out the pipeline, but also the associated equipments and bring the purity in the oil. In this, flushing is high velocity flow of low viscosity fluid through a pipeline or a component or a cavity. So in this, I think the machine that you have had from Minimac, you can use it for pipeline flushing or associated equipments. You can flush simultaneously. So in that case, you may find a lot of equipments into the field, whether into pre-commissioning stage or at shutdown stage, where you can use this equipment. A few live cases of flushing failure that we have recently witnessed. Number one is a refinery project in Oman, where project slipped its timeline due to improper compressor flushing. So you may also note down these things. A compressor flushing is important, and when compressor flushing was not done, the project timeline was slipped. So in case of where new compressors are, uh, taken into some project, you may use the flushing skid, and you see the cost of this loss was approximately $5 to $6 million. Another example, if we see, is a steel plant project in India where there was a failure in turbine driven blower after the commissioning because they did not flush the system before taking it into work. So in a steel plant, the loss was approximately $10 million. Application was turbine driven blower needs to be flushed. Another example you see here, a thermal power plant in India. This is a very common problem in all over the world. They are using servo valves, and servo valves itself is very costly part. And due to degradation, uh, the servo valves choked and were not able to continue. So the cost of this was approximately $3 million. So along with this, I have also given you three examples where you can use the flushing machine, maybe in a refinery, in example first, in second example in a steel plant, and in example 3 in a thermal plant or any of the power plant. I will also cover the stages where you can use the flushing machine. So your sales and BD people can also note down these activities. Along with this, the people who are going to site can also pitch your product when they are meeting a few people that this application you need to do and create awareness. So in actual practices, when people visit the customers or at site or do interaction on a frequent basis to people, there are certain myths or misbeliefs that they come across. Along with this, the number one is oil flushing is only a pre-commissioning activity. So people do believe worldwide that only in pre-commissioning stage flushing has to be carried out. But in actual, along with pre-commissioning activities of an equipment, flushing can also be carried out in a plant shutdown or turnarounds during any breakdown maintenance activity or in case any breakdown has happened, also during the oil replacement. So these are the four stages where flushing can be carried out. The other myth that we come across is on-site oil flushing is redundant if rotary equipment was factory flushed and tested by OEM. So people do believe that if the original manufacturer has done the flushing of this part, then there is no need to flush. Instead, even if in times we have seen that the flushed equipments or the pipelines also do carry certain impurities, the debris or the welding marks, especially the rusting is present there. You can see the photographs. So normally all the fabricated lines or the interconnected pipelines, any other fabricated equipment may have impurities if it is not properly flushed by the OEM. So in that case, even if the OEM is claiming that this is factory flushed, you may still ask for the people to have a check, and there are chances that you may get the opportunity to flush it properly. Another myth is oil flushing is an activity is chemical cleaning has been performed properly, then there is no need of oil flushing. So in that case, if you can see the photographs here, traces of water and chemicals which are mixed into the oil after cleaning of pipeline. So if chemical or water from chemical cleaning which was performed, so if any traces of water is present or chemical is present, so as soon as you put in the oil, as soon as your client puts oil into the system, it will get emulsified, it will get mixed with water, it will get mixed with the chemicals that were left behind. That chemical need not to be filled in system, but also it can be stick to the walls of the pipeline. to the sides of the equipment. It can be anywhere. So in that case, oil will degrade instantly the moment it comes into the contact of water or the chemicals when it was performed for chemical cleaning. So even after chemical cleaning has been done, oil flushing is a mandatory activity. Moving on to next myth that most of people come across is efficient oil flushing happens at very high pressure. So this is exactly not how it works. For flushing, a Reynolds flow calculation is present. I will also share this formula with you, or it will be easily available across the web. Reynolds number calculation, we call it. So in ideal conditions, for flushing to be very effective, Reynolds number should be greater than 4,000. So in that case, if Reynolds number is more than 4,000, the turbulence is created in the oil, and with turbulence created, it is best suitable for oil flushing. So this is a very general and a common myth that we come across even at Minimac. So this your team also may come across that we need high pressure, pressure of 100 or 200 or 400 bar. So in that case, we just need to ensure that the flow needs to be turbulent, which means Reynolds number needs to be greater than 4,000. So in that case, fluid pressure will not play a major role, but instead, flow rate calculation will be playing the big role. Any questions till now, gentlemen?
No question yet.
Thank you. Moving forward, another common myth that we see, oil flushing flow rate is decided based on largest diameter pipeline of lubrication system. So in this case, it is not just the largest diameter pipeline of the lubrication system, but also the branches of the pipelines. Suppose there are multiple pipelines coming out of the bigger pipeline. So in that case, all the pipelines need to be flushed properly. So this is a complete myth that our biggest pipeline being 4 inches, 6 inches, or 8 inches. Instead, we should also consider the branches of the pipelines. This is a very common case where uh, hydraulic power packs are used, or in case the heat exchangers are used. You can see in the photograph here, a skid is made up and multiple lines are coming up. So the bigger pipeline might be having larger diameter, but certainly we need to consider the small pipelines also, which are coming out. So when you are calculating for the flow rate calculations or the flushing where needs to be done, in that case, you need to consider all the pipelines which are associated to the system that we are going to flush out. Moving to our next myth, oil flushing is all about attaining and generating reports on NAS 1638 or ISO 4406. These are standards for oil cleanliness. So it is a very common myth that if the NAS or ISO values are attained, so the oil is very clean. So this myth is, in fact, we are experiencing a worldwide myth. So in that case, you see the second photograph and this along with the test report where it says, as per the report, the oil is clean and good to proceed ahead. But when you see the mesh, in mesh inspection, you see multiple particles are present in the oil. So in that case, particles are still present and NAS reading says that this is clean and good to go ahead. How this happens, I will tell you. When you draw a sample of oil, So it might carry the particles or it may not. So in that case, when you are doing actual mesh inspection, so certainly a larger volume of oil passes through, and in that case, there are more possibilities to get the exact particles which are present in oil, which you are seeing here. The particles were captured, and in this case, the particles were not present. This also has one more chances that the particle counter is showing error. So in that case, mesh also gives you exact scenario where particles are present and needs more flushing. Any doubts, gentlemen, in this slide? So I'm moving to our next slide. These are the common oil flushing challenges. You see, this is a very simple picture. The challenges. Oil flushing is a milestone activity. Oil flushing has to be performed yesterday. Shortage of specialized manpower and equipment. These three are the major challenges that you will face in site. I will go on one by one, explaining this first. When you are doing the flushing, the most common challenge that you will face is the shortage of specialized manpower and equipment. Now, in that case, we have already the equipment. Along with this, the manpower needs to be trained. So, if this is completed, so in that case, whether the flushing uh, opportunity comes to JC International, in that case, you may immediately mobilize the manpower and equipment. So this challenge will be completed now. After this, the oil flushing has to be performed yesterday, which means when you are going to a pre-commissioning site, always we have to plan a step before. So in that case, the oil flushing needs to be done in advance, or all the arrangement for flushing needs to be done in advance. Similarly, in this first point, you see oil flushing is a milestone activity. In this, you need to ensure that the milestone has to be specified that we will be flushing your system until this milestone is achieved. Milestone can be NAS value, ISO standard, or mesh inspection that we have seen in previous slide. I will just showcase the previous slide where this was mentioned. So you see NAS class, ISO class, and mesh inspection. These three could be the defining parameter of the milestone that has to be achieved for oil flushing. Because at some certain point, when this milestone is achieved, this activity has to be considered as completed and flushing is done. These are the five cornerstones of oil flushing. These are the key parameters which you need to consider when you are taking up a project for oil flushing. This is the Reynolds number calculation formula, which I was describing previously to calculate the optimum flow required for the flushing to be efficient. So this very formula, you can note it down or take a picture, and this will also be shared post this meeting. So this formula is applicable to all the applications of flushing, and this will be a key parameter to decide the flow rate required. In this, you need to have some certain parameters of oil, the pipeline which needs to be flushed, and certainly then you can describe the flow rate required for flushing system. So this picture itself describe all the parameters. Number one is flushing flow rate, which needs to be calculated from here. Number two will be fluid viscosity. Lower the fluid viscosity, more are the chances of obtaining the better cleanliness. In this case, I would certainly tell you, if you are flushing with oil of 32 CST or VG32 hydraulic oil, so you will certainly find Reynolds number more as compared if you use a higher viscosity. whether 68 or more. If you are using higher viscosity, cleanliness would be lesser because Reynolds number will be less. So you need to ensure that fluid viscosity is as less as you can use up. After this, number three is oil temperature. Oil temperature has to be maintained between 40 to 60. At maximum, we can go up to temperature of 70 to 75 degree Celsius. Number four is efficient filtration, which is the very important step in a flushing skill. Whenever you are flushing an equipment, so in that case, at first, all contaminants are continuously added from the system which is being flushed to the oil because of high velocity of the fluid. So in that case, a lot of particles come into the oil. So to remove these particles which are now circulating into oil, we need a very efficient filtration. So if any customer, any client asks what is filtration criteria that you have, so in that case, we are having a very efficient filtration from MP filtering, which is fitted in your skid. This comes from MP Filtry Italy, the filters. So the efficiency will be very good and certainly the particles will be trapped very easily. Number five is fluid testing. Now, if we have done all these pointers, flushing flow rate calculation is right, fluid viscosity is done, oil temperature is also optimum, and filtration is also efficient. Now, the last part is fluid testing. So as we discussed that this is a milestone activity. So to reach a conclusion that this milestone or NAS value is achieved, the NAS value is okay now. So in that case, we need to test the oil which is being circulated, the oil which is used to flush the system. So for this, we will have to draw a sample of oil, or in case you have the a particle counter, so you can simply test the fluid and get the results. If the results are as per milestones, certainly we can consider that flushing is completed. So if anyone from sales or BD can confirm that all information is noted, or you need any additional details on any of these points?
Yeah, I have a question here. We were on a job and the client requested that we take the temperature to 80 degrees there, but you just mentioned the maximum 75 degrees. Was it wrong to take it to 80 degrees?
No, it can be taken to 80 degrees maximum, but it is recommended to keep below 80 degree. Why I am telling you? The hydraulic oil has some certain properties. The oil which is taken up for flushing. So in that oil, it is recommended to keep it below 80 degrees Celsius, or it starts to degrade. So to prevent oil from degrading, we certainly ask people to keep it below 80. It is the maximum level of temperature that should be taken up.
Okay, that's noted. Thank you.
Any more questions? Because most of the questions will be faced by sales and BD people. So I would welcome more people if you can share your queries. So we will solve all the queries one by one. And if I'm going fast in any topic, you may please let me know. I will slow down. Okay. So here you see flushing flow rate, which means how you have to calculate the flow rate required for efficient flushing of a system. Number one is turbulent flow. The formula we have already seen in our previous slide. Your calculation should ensure that Reynolds number is more than 4000 at any point. So in that case, you see particles of fluid will have a turbulence effect and certainly efficient cleaning. Number two, each parallel branch line must have a turbulent flow. This is what I told you. where a bigger pipeline is going in as a mainstream pipeline, and it has multiple branch lines. So in that case, not only just the bigger pipeline needs to have a turbulent flow, but also the parallel lines which are running through the system or the other equipments that are into the uh, branch lines needs to have a turbulent flow in this. So the entire system will will be flushed out. Number third, flushing pump must have sufficient back pressure handling capacity. In most of the cases when we are doing flushing, so there is a certain back pressure from the equipment that we are flushing out. So the pump must be capable to handle that much back pressure. So which means the pump should be generating enough pressure. In your case, I think the skid is having a maximum pressure of 60 bar, which is a quite good range. So all your calculations which you will be doing must ensure these 3 pointers. So you can pitch your product to clients. Next is fluid viscosity. I already told you the lower the viscosity of the fluid, the better the results will be. If you see here, this video, this video, you see the viscosity where it is less, the fluid is flowing easily. And if fluid is less viscous, so in that case, the flow is not sufficient. So in this regard, the fluid viscosity should be as less as possible. Also, in the first picture, if you see, the high viscosity fluid will be filled less, whereas if we heat up, the viscosity goes low. The low viscosity fluid will be more. So in this, you may find oil data sheets where it is mentioned that with a rise in temperature, oil viscosity will drop down. So low viscosity flushing will enhance the turbulence of the oil and efficient flushing will be done. Yeah. Here it is regarding the oil temperature. You see, as the temperature rises, the viscosity of the oil drops. This is a very small chart. I will share this chart separately. I'll try to. So different fluids are taken up. So any of the fluid, if you see, when temperature rises, the viscosity graph drops off. So this is a very simple physics where you are heating some fluid and the viscosity is dropping down. So you see, this is a picture representing a simple flushing that most of people were doing. And now if you see high velocity flushing with proper Reynolds number calculation, you see there is a turbulence which can be seen. So that's the difference between a normal flushing and a high velocity flushing. So the skid that you are already having is compatible to this high velocity flushing. You just need to do the calculations that we have discussed in our previous slide. And with this, you may see the before and after results. This is at one of our sites where there were a lot of particles inside the pipeline. You see rusting particles here. And after all the flushing was carried out, you see now it is absolutely clean with naked eye. One more thing which the site people can have a look at is the mechanical shocks along with thermal shocks. And this, if you see, we will be certainly providing a hot oil flushing. There is a heater in this kit, and when you flush out the system, due to friction and due to the heater, the oil temperature rises. So when the oil temperature rises above 70 degree or nearby 60, 70 degree, after this, you need to slow down the heating and you see temperature goes down here. Then again we have to heat. So this process is called thermal shocks, where you provide different temperatures. So heating and again cooling and again heating. This shock uh, helps in losing of all the debris that is present into pipeline, all the welding debris or any material that is stick to the walls of the pipeline. So this is called thermal shock. Along with this, you also need to provide mechanical shocks, which is hammering sort of action. So you need not to hammer too hard to damage the pipeline, but mild shocks from a hammer or some other similar equipment may also result in losing of the debris inside, or all the welding marks, welding spots that are present, they may also lose up and flow with the oil now. So this side people can note down that not only just flushing, you need to provide mechanical as well as thermal shocks. So this will help you create a debris-free pipeline and proper job execution. Any questions from site team? Because you people will be present on site to face customer, whether the oil is being flushed, the equipment is fine now. Well, we will proceed to next slide then. Efficient filtration. So now since we have been learning regarding the flow, regarding the process, how we are going to flush, another important parameter is efficient filtration, in which when the oil is continuously being flushed, the equipment is being flushed, so all debris comes into the oil itself, and we need to collect these particles from oil itself. So you see, it is different parameters where you need to collect the debris which is flushed at downstream. We also need to ensure that the fluid is super clean at upstream, and also you need to ensure filter, the filter micron selection, filter efficiency, and dirt holding capacity. So these data sheets will be present with you, or if in case it is not present, we can share it again with you. Now, oil should be very much clean when we are starting the flushing process. After this, when oil goes into the equipment, and now at downstream side, the oil should be full of debris. So at this stage, filter has to be come up and collect all the debris which you see here. There are different filters that are provided in the skid that we have manufactured, and in this, at the return line, you see there are filters which are installed. So when you flush, these filter will capture all the debris that comes out of the equipment that you are flushing. So this will contribute to efficient filtration of the equipment. Next is regarding the fluid testing. I told you there are three different parameters for fluid testing, which can be considered for milestone activity. Both site people and sales and BD people can note down these points. For fluid testing, this will be end parameter to conclude a flushing activity, or even if you are going to discuss the stages of flushing, that when this activity has to be stopped. So every person can check these values with the client. There are three parameters of fluid testing which completes the flushing as a milestone. Number one is mesh inspection as per API 614 standard. You see a clear mesh is present, which concludes the flushing now. Number second is NAS 1638. There is a NAS chart present, or if required, I can also share with you. Number three is ISO 4406, the particles distribution. So these just three parameters which you need to check with client or at site when you are flushing. This needs to be predefined by people. And when you are working at site, when these three parameters are achieved, you may conclude that flushing is now complete. So people of sales and also people who are at site may use this information. Okay, this is a typical flushing circuit where you see this is a pump. This you can consider as a flushing unit that we have manufactured. It has a flushing line filter upstream at upstream. After this, this is a lube oil system pipeline which needs to be flushed. So oil from here goes into this system. Oil is drawn from a reservoir with heater. This tank, you might have seen it is present in this kit. So after this oil tank, it goes into the pump, which goes into the line filter. After this, you see this oil is distributed into this entire system. After this, all the debris and oil comes into the return line filter. This return line filter collects all the particles that are coming from the system of lube oil or the system which is flushed. And after this, after filtering the oil, after capturing all the solid particles, this oil is now again filled to the oil reservoir. This reheats the oil and again circulates. So this is a very general arrangement of flushing circuit. These are a few of the kits that we manufacture. This is a lube oil and chemical cleaning kit. After this, these are lube oil flushing kits. These are a few of the reference standards that we follow. So these are multi-purpose kits and can be used for various jobs.
Excuse me, please, can we go back to that, the previous slide? Yes, for the skips, for the equipment.
Okay.
Yes, this one. So this equipment can be used both for chemical cleaning and lube oil flushing. Is that correct? The green one?
Yes, it can be. It can be used.
Ah, okay.
But a few things which need to be considered in this. When we are doing chemical cleaning, so in that case, particle counter cannot be used because particle counters are not.
I hope we can talk more about this later on, maybe after this meeting.
Yeah, sure, no problem.
Thank you.
These are a few of the reference standards of flushing worldwide. All these standards are through the OEMs like Solar Turbines, GE, or various agencies here. So these all are the standards of flushing. These are a few site pictures of our machines and the offerings that we do, which are mentioned here. Not only the machine supply, we also do services. We also provide expertise, manpower, training sessions, and a lot more. In this, you can see the other equipments that we have in our fleet. These are oil purification systems for different problems that are being faced, and a few of the case studies which are Minimac experiences. This will also be useful to your people, where you can see we were discussing that a gas compressor at pre-commissioning in Oman was the challenge being faced. Heavy sand debris found in lube oil circuit. So solution is flushing flow based on flushing fluid viscosity. So the challenge faced with this was that there were heavy sand inside the pipelines of the compressor. So in that case, we installed our machine with efficient filtration solution being provided. So in that case, all the debris that was flowing into the oil was captured and flushing was declared as successful. Another experience is in Kazakhstan that ambient temperature of project site is sub-zero range. So you see Kazakhstan being a cold country, there the temperature dropped below zero. This challenge was faced. I believe this challenge might not be faced in your area or your zone. Okay, this is an example of turbine blower flushing at steel plant in India. So in that case, you see our machine is installed and still heavy debris was found in the oil. So after multiple attempts, this flushing was now completed and mesh inspection showcased that this flushing is now complete. You can see the pictures of the mesh here. So in this scenario, I will tell you what happened. Some other person declared that this flushing was done because of the particle counter, which showed that the results were satisfactory. But in real condition, at mesh inspection, a lot of particles came up. So with mesh inspection, API 614 standard, now we did conclude this site. So not only the particle counter showing the value, but this mesh inspection will be a crucial game changer in flushing case. So you need to ensure with the client that we will be doing this mesh inspection. This will certainly give you more time on schedule and certainly more rentals. I will tell you that it is easier to get purity levels at a particle counter, NAS values, but it will take more time to get this mesh clear. So if you are going for a per day rental or a monthly rental basis, rental of your flushing skid, so in that case, you may pitch this mesh inspection as the criteria. Alright. Flushing is the first step of machine reliability. You need to make it mandatory, not as an option. Flushing should be mandatory in case. Thank you. So that's all from our side, and we welcome your questions. Jimri.
Thank you very much.
So I hope I have given you a very good idea where you need to pitch your product, your flushing machine. Your sales and BD people can discuss these points with client. The people who are working at site, once you get the order, so they also needs to be educated in a similar fashion. So I hope this information was good to you.
Okay, thank you so much, Amma. Do we have any question for him, please? Okay,
There is no question from Uganda, at least. Everything is clear. We'll be waiting for a copy of the shared presentation. Thank you.
Okay, Port Harcourt team, Lagos team, do we have questions?
None for now, Claret.
Not for now. I don't see any questions from this side yet.
Okay, but I hope we understood all that he has said?
Yeah, sure, we did.
Yes, we
Okay.
did.
Yes, we did, but we look forward to receiving the presentation slide for our further studies and go and recording too.
Okay, so Amal, no question from the team. So as agreed, we are looking forward to receiving the presentation slide. Amal, can you hear me?
Yeah,
There
sure.
is a network issue.
We'll be
Okay,
sending
so when
you
are we
the
expecting
details.
to receive the documents?
Yeah, we will send you the PPT copy of this presentation. We will also
Sorry?
share you the recording. We'll share you the PPT, the presentation, and we will share you the recording. And we will also share you some other informative videos which are available on the YouTube for you to see and also to train your people.
Thank you very much, Mr. Aman. I think the presentation went very well.
Okay, thank you for being a nice audience. If you guys have any more queries, any specific topic you would like us to cover, you can
Thank
let
you
us
very
know.
much.
Yeah, we will be most overwhelmed to give you presentation on those topics as well.
Yes, and I would like us to talk about the chemical cleaning and a loop oil flushing equipment, the green one later on.
Yeah, sure. We will discuss that.
Yes. Thank you. I appreciate.
Yeah, Amal, you can share your email ID on the text chat.
Yes,
so that
I will.
all
I
the
will.
members. Yeah.
Yes.
Amal can send it out.
Claret, I'm sure you will share all our email.
Yeah, you can
Yes,
send the
sir.
email IDs for all the participants.
Okay, so
So we will
Amal,
share
you
the
can
information.
just send to the email we've always used in the email correspondence between me and Pragati. I believe you've been in copy of the email, so you can just do reply all and then attach to the email.
Yeah,
Yes,
sure.
I have also mentioned my mail ID in the
also.
chat box, and I am present in the mail with Pragati that you people were interacting with.
Yeah.
And
You
our
can give
guys
it
will
to
also join the WhatsApp group.
Yeah, we will be sharing the link
Okay.
of the WhatsApp community, and
Yes.
all your people can join the community there.
Thank you.
Yeah.
Okay, Mr. Aman.
I'm already on that group already, so I see their stuffs every time, every day.
Yes. Thank you very much. Bye.
Okay, bye-bye. Thank you.
Bye. Thank you for joining. Have a good day.
Yeah, thank you.